Integral to complex and solving square roots, day 2. Today we're going to introduce the imaginary number I, and I is calculated by solving this simple equation here. I is the square root of -1. I is used to help describe or explain the solutions to a parabola who doesn't touch the x-axis. So we are going to investigate I by starting out with simple solvable problems and therefore coming up with imaginary solutions to these simple problems. Notice that the square root of a negative number cannot be found using real numbers. So we introduce the value of I with this simple breakdown of the square root of -5. We simply rewrite this using two separate radicals, and when we do that we get I times the square root of 5. And that's the process by which you will follow when you are solving each one of these problems that has a negative number within the radical. Even though I will not write these steps, this is exactly what the process is. Alright, same thing happens over here. The I comes out, we break down 12. We break down 12 into 4 and 3. 4 is a perfect square, 2 and 2. The 2 comes out. 2I square root of 3 is the way to rewrite this problem. Notice the radical is does not contain the negative sign, therefore this is a real solution, not an imaginary one. So this breaks down into 4 and 10. There's your perfect square. It becomes 2 square roots of 10. Negative. This one, you'll notice, is a little bit different in that the negative is inside the radical symbol. Therefore, we will begin by placing our I outside. Placing the I out in front does not disqualify us from still breaking it down, and we still get the exact same answer as before, although instead of a negative, we now have an I. Likewise, here's our perfect square of 5 and 5, so that means it's going to be 2I times 5. That's 10I. Break down 24 into 4 and 6, and we break that down to 2 and 2. Your 2 multiplies by the 3. Remember, there's a negative here, so that makes it an imaginary solution. So here's what the simplified response looks like before combining like terms. -3I times 2I. The 2 came out, the I came out, times the square root of 6. We multiply our like terms together, and we get -6I squared times the square root of 6. I squared from before is -1, therefore it's -6 times -1 square roots of 6. Negative times a negative is a positive, and the answer is 6 square roots of 6. Alright, before combining your radicals or simplifying them in any way, we must acknowledge that there's the negatives inside the radicals and remove them and replace them with I. So this becomes I square roots of 5 times I square roots of 8. That becomes I squared, because I times I is I squared, times the square root of 40. Square root of 40 from before is 2 square roots of 10. I squared from before is -1. So that becomes -2 times the square root of 10. That's 3I square roots of 6 times I square roots of 3. Remove your I values before simplifying. That's 3I square root of 18. Sorry, 3I squared square root of 18. That breaks down into 9 and 2. There's your perfect square. It comes out. So that's 3 times 3, which is 9. I squared is -1. So that's 9 times -1 times the square root of 2. So our final answer is -9 square roots of 2. Likewise, -2I square roots of 2 times I square roots of 6. Now we multiply them together. We get -2I squared square root of 12. 12 breaks down to 4 and 3, as before here. And now we can simply rewrite as 2 square roots of 3. Sorry, let's try that again. 2 times 2 square roots of 3. which is 4 square roots of 3. I've taken the liberty of filling out the eye chart already. Please make sure that you fill out the eye chart as well. The most important thing to remember about this is that it's cyclical. It goes through a cycle, and that cycle is 4 units long. Okay? And we will use these 4 units here to help us solve problems that involve larger values of I. So using the chart, we're going to go ahead and fill in what I to the 29th power would be. Now, rather than writing out a whole long list of numbers, what we're going to do instead is I'm going to simply divide the number 29 by the number in the cycle, which is 4, and whatever that value is, don't care about the whole part, it's just the fractional part that's left over. That's the part that I'm going to focus on. The fractional part left over, or the decimal in this case, is 0.25. So that means that I will be using I as my answer to I to the 29th power. Likewise, I will be dividing 100 by 4, the number in the cycle, and I'll get a whole number. That's the important thing to remember here. It's 25. There is no fractional or decimal left over. Therefore, the answer to this question is 1. 301 divided by 4 is going to give me my solution, and the decimal value left over here is again 0.25, and that makes the answer to C, I. Instead of combining these together, because I can't, I'm going to instead solve them individually for their values. So I to the 17th is going to be 0.25, and I to the 35th has a decimal portion of 0.75 left over. That means that my first value is going to be I, plus my second value, which is negative I. I minus I is 0, therefore the answer to D is 0. Moving down here, what we're going to do is we're going to look at each individual value separately, and I do believe that this was a typo, but it's left in there, so we'll just go ahead and go with it. So we'll start with 201. So 201 divided by 4 is going to give you 0.25. So that means my first value is 3I plus 7. The I to the 72 power is going to be a whole number, so that's going to give me 1. I to the 29th again is 0.25, so we're going to go make that negative 6 times I, and add 8I and our random typo there. Combine your like terms, all of your i's, make your real parts come first, and so we'll go ahead and write it as 7 minus 7w plus 5I. Finally, I to the third, which was negative I to the 13th, that's going to be I, and I to the 52nd, which is 1. Use the distributive property to combine these together, and you get negative I squared minus I. So that's going to be negative I squared, which is negative 1. So a negative and a negative is a positive. That becomes 1 minus I. And there's your final answer. The next thing we're going to look at is what complex numbers are. Complex numbers are comprised of a real and imaginary parts. They are used to help us describe the solutions to parabolas that have no real solution. The real part is written at the beginning, the imaginary part is written at the end, and has the I attached to it. We can combine our terms much like we do with rules of algebra. Just make sure that you are following those rules and making sure that you are not making up your own math as you go along. Distribute through there and you get 2 minus 3I minus 14 plus 7I. Combining like terms and rewriting your real parts first, you get negative 12 plus 4I. Distribute in your values, and that's going to be 6i minus 21i squared. And finishing that off, remember I squared is -1, so 6i equal 6i minus 21 times -1. Simplifying and rewriting with your real parts first is 21 plus 6i. Use double distribution or the FOIL to help you solve this problem. You get 8 plus 14i minus 12i minus 21i squared. Combine your like terms and you get 8 plus 2i minus 21 times -1. Rewrite with your real parts first and you get 29 plus 2i. This is a perfect square trinomial. That's a squared minus 2ab plus b squared. So therefore it becomes 9 minus 24i plus 16i squared. Rewrite and simplify with your real parts first. -7 minus 24i. Complex conjugates are numbers where the real parts are the same and the imaginary parts are opposites of one another. Okay? We're going to go ahead and look at some examples here and make sure that we understand complex conjugates before moving on. Okay, so the complex conjugate of this is going to be 8 plus 7i. Regardless of whichever is written first, please make sure you only switch the complex part. The real part does not get switched. Okay, in order to simplify a number that has an imaginary part in the denominator, we simply multiply the bottom and the top by its complex conjugate. So we multiply 1 plus 4i, 1 plus 4i. Now we're going to use those same rules of algebra that we used before, and we're simply going to multiply them together. Okay? That's going to be 3 plus 12i plus 2i plus 8i squared. Complex conjugates cancel each other out, much like a squared minus b squared. The difference of two squares cancel one another out. The imaginary parts are removed, and what's left is your answer. So you get 1 squared minus 16i squared. Your imaginary parts in the middle are canceled out. Okay? So then what's left here is, once you simplify and remove all of your values, you get -5 plus 14i divided by 17. Over here, we're simply going to multiply by 5i. Well, technically -5i. Thank you, because it's the opposite. Because you could technically rewrite this as 0 plus 5i, so that has to be 0 minus 5i as its real part. Multiply that through. And we get 20i plus 5i squared divided by 25. Reducing with the greatest common factor, you're going to get 4i plus, minus 1 divided by 5. And there's your final answer. Rewriting with your real parts first, you're going to get -1 plus 4i divided by 5. Please pause at this time, move on to the next two examples before continuing or resuming the rest of this video. The other two examples are already done for you. Please check your work against what I am going to show.